Hi, I'm Dave Robinson and welcome to Makino's EC Live. Today we're going to talk about the EDAF version C. So these are the improvements on the version C machine. So we're going to show you a little presentation and then we're going to do a walk around out at the machine in our showroom. So let's get started. So the first thing on the version C, we want to talk about the improvements. The work tank flow pattern. So this has changed from our previous models. What we've done is change the direction of the flow for more high efficient chip removal. So what that does is it takes the fluid from the back of the machine to the front of the machine instead of that tornadic movement that we had previously. Second, adaptive control. So what the machine does is analyze and self-adjust its machining behaviors to make the machine more efficient. Number three, the new HS rib cooling system. So we've had the HS rib system now for 5 or 6 years, and we've done some adjustments to that on the cooling side of it. So this is a continuous circulation of cooling oil. And then lastly, the filtration system. So we have a more high efficiency system for cleaning the oil and then creating that circulation. So right now I want to show you a little video of these same features. So now that we've seen the video, I want to talk about each one of the sections of the improvements of the machine. So the first one, the new work tank flow pattern. So you can see here, this is the rear of the machine. So the port outlet of the machine, where the oil comes into the machine, is in the back. And then the flow is towards the front where the overflow ports are. So the reason we do that is to take that debris out of the machine as quick as possible. We don't want it to get back into the machining area and be remachined. This creates a better surface finish and a better melting edge. So here you can see work tank left side view, so port outlet coming towards the front of the machine. So I just talked about improved edge quality and surface finish. So what that does with that better surface finish and the improved edge quality is that minimum melting edge. So we don't get that debris on the top of the edge that has to be removed by hand or polished off because of that improved flow. It takes that material off and we don't get that redeposited edge on the part itself. So this improves the fine edge quality as well, and then also enhances the surface finish. So the machine is equipped with smart logic control to streamline that flow at a smooth rate without mixing the debris in that tornadic motion. It's more of a laminar flow from the back to the front of the machine. So what that does is eliminates the pinholing and also gets a better, more consistent surface finish. Next improvement, new adaptive control function. So our adaptive control basically controls the machine during its machining. It monitors the spark, monitors the jump. So with the new adaptive control, it is called AiSF. So this is an adaptive spark function. What it does is the cycle time now is adjusted, the jump cycle, according to the stability of the machining process. So what that does is shorten the cycle time of the machining. How it does that is basically as the machine gets in trouble or that spark basically is ineffective, or the effective pulse weakens, it increases that jump frequency. Previously, most machines would add off time to stabilize that function, and what that did is increase the cycle time and also increase the wear. So now by just adjusting the jump, we don't get that cycle time increase. Also, one of the features that's a resultant of that is a uniform wear on the electrode itself. So you can see a photo here that we get a more consistent electrode wear. We don't get buildup on the corners of the electrode, or we don't get the abnormal wear. One of the results of that is no arcing during high-speed machining, so that adaptive control basically makes that very optimized. So it's automatic software adjustments that include jump settings and also that reduction of machining time. So again, here it shows the adaptive control side in the wear. So with no adaptive control, we get a small buildup on the corner, where with that AiSF, we don't get that buildup on the corner, so there's no damage or buildup to the electrode. Next feature is the new high-speed cooling system. So this is the high-speed cooling on the HS rib. HS rib is the 20 meter per minute jump in the z-axis direction at 1.5 G acceleration. So here's a little view of the cooling loop itself. So we have the machine oil-matic. So this is the dielectric chiller. So it goes from the dielectric chiller through the heat exchanger, from the heat exchanger to the spindle itself, and then also connected to the bed tank. And then the heat exchanger in addition is connected to the z-axis. So we put cooling through the z-axis and the spindle through the motor block and core cool the ball screw at the same time to take any of the thermal growth or the thermal heat that's created in that 20 meter jump process. So we get a faster machining time with that thermal stability, that we don't get growth. It's a much more robust z-axis. Again, 20 meter per minute jump, 1.5 G acceleration, and generally about a 30% time savings with the HS rib system over standard jump. Standard jump is only 5 meters a minute, so 4 times as fast jump. The faster we can get back into the cut, the faster the machine's going to advance and remove material. So it also has stable thermal control, so that heat exchanger, again, for dissipation of heat and to preserve the accuracy or high accuracy of the machine. Lastly, the new filtration system. So we've created a new filtration system. So we go from the bed tank through our filtration, so the filters themselves, and then we introduce only clean oil into the work tank. Previously, the machines would only filter the oil that came from the bed tank, and it would fill the work tank with what oil was available from the bed casting. So now any oil that goes into the tank itself has been cleaned. That also is a good result on the surface finish side as well. Filter usage range has increased. Previously it was only from 0.1 to 0.2 MPa. Now we go to 0.3 MPa. What that does is gives us 10% more filter life. Also, the diameter is smaller and lighter. It's a smaller filter. So previously it was a 400 millimeter filter. Now we are down to a 210 millimeter diameter filter. It also uses thin paper technology. So it gives us more paper and more surface area to trap that debris in. So it's a much more efficient system on the filtering side. With that filtration system, we've taken those canisters. We've taken them from sitting vertically, and now, like you see in number 1, they sit horizontally. So with that, there's less parts to remove. It's a much more simple maintenance system to change the filters. So we have the canister itself, the paper filter that's inside, and just 2 parts to remove to get to that paper filter. So there's the lid and then the nut itself that holds the filter in. So, and with this canister system, 100% airtight system, so less chance for leaks. So the filtration system is really an efficient supply of clean oil. So really the biggest features are the direct transfer of clean oil from the filtration directly to the work tank, where previously there would be some particulate in the oil. 30% faster to obtain that clean oil, so much more high efficient system with that thin paper and more surface area. And then sustainable filter life, that we get 10% longer filter life on the filters, so really saving money at the same time as being efficient. So we're done with the presentation side of the EDAF improvements. So I'm going to go ahead and walk out to the machine now and do a live walk around of the machine. Okay, now that we're out at the machine, we're going to go ahead and go through each one of the features we had talked about in the presentation and do a live walk around of the machine. So the first one we want to do is tank fill, to show you where the tank flow comes from. So I'm going to go ahead and fill the tank. You can see that it comes from underneath. It flows from back to front. So once the tank gets filled, the float upper hits, then we can see that laminar flow from the back of the machine to the front into the overflow ports. That's what's going to carry that debris out quickly and get it out of the burn area, give us better surface finish, better melting edge. So now that the tank flow is stabilized, you can see the flow coming towards the overflow ports. So second feature we talked about was the AiSF, or the Adapti Spark function. So I'm going to go ahead and run a program, a rib, to show you that Adapti Spark function in action. Also, you'll see the 20-meter jump of the HS rib as well. So electrode rotates 90 degrees, comes down to our start point, and then we start to burn. So at this point, you can see the AiSF on the screen active. So that's the Adapti Spark function. That's our adaptive control. So anytime the electrode gets into trouble or it has problems, it stumbles, that there's debris in the way, it's going to then continue to jump instead of adding off time like it did previously in our P-pulse adaptive control. So at the same time, you see the 20-meter jump again. So a 20-meter jump, 1.5 G acceleration. So that rapid jumping motion is what's taking the debris out of the cut. And you can also see at the same time that laminar flow of the debris heading towards the front of the machine to go out of those exit ports and get out of the way. So the next feature we want to talk about is the new improved filtration. So filtration's in the same spot, but filtration has definitely changed. So again, smaller filter, 210 millimeter diameter filter, opposed to the previous 400 millimeter filter. The thinner paper, so we have more surface area. So you can see here, nice catch tray to drain the oil. So the system sets now horizontally instead of vertically. So much more efficient system, about 30% faster for turnover of oil. So nice filter replacement procedure on the side of the machine as well. So very simple, easy to change filter. So the last feature I wanted to show you today is the heat exchanger. So this is the heat exchanger that cools the Z-axis. So this is what cools the Z-axis stabilizer. We pump the Makino spindle lube, same thing that's in our mills, up through the Z-axis, that core cool ball screw, also the motor blocks as well. So that takes any of the thermal growth out of the spindle itself and the Z-axis at the same time. So that's how we hold that precision and depth control while still jumping in that 20 meters per minute at 1.5 G acceleration. All that concludes my presentation for today on the EDAF version C, the upgraded features of the EDAF. I'm going to go ahead and head back into the EC Center to take questions. Down in the lower right of your screen, there's a chat feature. If you'd like to ask any questions about any of the sinker content or anything we covered today, please feel free. So ask any questions. Thank you. So if anybody has any questions, go ahead and use the chat feature there in the lower right-hand corner, and yeah, we can answer any questions about the EDAF machines or any of the Makino sinker products at this time. So if you want to go ahead and get some questions going, I'll start answering questions. First question we have, what does the heat logo on the front of the EDAF mean? The heat logo is actually our digital generator. So a few years ago, we went to a full digital generator. It's referred to as the ES200A generator. So this is a full digital generator over our analog generator that was on the previous, or the A version of the EDAF. So the B version is what went to that ES200 digital generator. So much higher efficiency digital generator. There's power savings, and then also a higher end generator as well. Any other questions from anyone? Yep. So another question. We have a 2019 EDAF 3 heat. Do you recommend using a manifold to move the fluid more in the work tank? On the older machines, yeah, it's not a bad idea to use a manifold system to move that oil around. One of the problems, though, is when you do use a manifold system, you really have to watch running the oil across the top of the workpiece, across the top surface, either from front to back, which is generally the preferred method, or better than side to side, but side to side if you have to. Setting up a manifold where that flow doesn't push the debris down into corners and pockets where it can get trapped, that can actually be counterproductive to the system. Where if you have that laminar flow, similar to what we've done on the EDAF version C for your older machines, running that laminar flow from back to front really works well to get the debris away from the burning area. And then, like we do with the version C, where we get that out into the exit ports of the machine, so it's not getting it reburnt by the machine. So yeah, a manifold could be a good benefit, but if used properly. Any more questions out there? Here's another question. Can you turn the adaptive control on and off? And if so, what would be some of the reasons for that? You can turn the adaptive control off. So there's some features in the older machines. It's called R level. So the R level is the sensitivity of the adaptive control. So we can actually set the sensitivity so it monitors less frequently and doesn't make changes. So it'll run a little bit longer, get a little bit more unstable, then kick that adaptive control in, what we call P-pulse, and then make those adjustments in the background, adding off time to the machine. Now, again, with the version C, the AiSF, it doesn't go to that automatic adding off time to stabilize. It increases that cycle jump where it jumps a little more frequently. And then again, by jumping more frequently, we don't add off time, which off time adds wear. It also adds cycle time. So that's part of that AiSF system for the rib side of it. So some guys adaptive control off for some copper details where there's a lot of feature to it. Sometimes the adaptive control can get in the way. So it can be turned completely off, but issue with that turning off of the adaptive control, then the machine doesn't have any control over its adjustments. It can't add off time or adjust jump or anything like that. And it runs similar to an old style sinker where you get what you get. Flushing is key at that point. If it arcs, it arcs. So adaptive control really is a good idea to keep on. I have another question from Eric. Is that adaptive control usable in model plan or able to use hardline in a macro program? So our adaptive control is turned on in a couple different ways. Really depends on how you program the machine. Inside of model plan, we use what we call a G132 line. So the G132 line, a Q value in the G132 line is what turns on the adaptive control. So a couple different versions, a Q1 at an IPL of 10 or above, the adaptive control will be on, generally in roughing processes. And then a Q of 2, you have adaptive control in all processes. So in roughing and finishing both, that's what turns on the adaptive control. The new adaptive control, the AiSF, for any of the users that now have the version C machines. So your EDAF 2 heat version C, it's actually turned on now, no longer by the G132 line. We've added a new line in model plan. It is called G142I, and an I of 1 is what turns on that adaptive control. So you saw the little screenshot there inside of the presentation itself, and that when AiSF is on, that G142 line is what activates that. One more question: how compatible is programming to your wire machines? So a big difference between a Makino wire machine and a sinker machine as far as programming goes. Wire machines are standard M&G code, similar to a FANUC style programming, where the sinker itself, all sinkers are very different in their programming language. Yes, our machine runs off of the Makino machines, run off what we call a model plan or M&G code programming in the background. And then with the new machines, they're all programmed through an onboard conversational system called Project. So our Project system takes those conversational inputs, turns those into an M&G code program, and then also can be brought back into what we call model plan programming that we've had for probably almost 40 years. So many different ways to program the sinker, where the wire machine is pretty much straightforward. You can program at the control in M&G code or post from a CAM system. One more question. How does the adaptive control reduce cycle time, and how does it protect the electrode? So that adaptive control reduces cycle time, A, by stabilizing the burn, and then not adding off time when it doesn't need, when it doesn't need to be there, especially with the new version C and the AiSF, that the minute the machines previously got into trouble, they instantly add that off time. Well, off time slows the burn down, so that takes longer to burn. So by adjusting the jump first as its first line of defense, that's where we get that cycle time reduction. And then again, the adaptive control, whether it's the P-Pulse style in an older machine or the AiSF, its primary goal is to protect the electrode. So we want to protect that electrode from arcing, which arcing is damage. So we either get buildup on the electrode itself, buildup on the workpiece, and that causes damage to the workpiece, which is the ultimate no-no in sinker, is damage to that electrode. If the electrode's damaged, obviously it's going to damage the workpiece. Any other questions? So we'll wait a couple more minutes, make sure nobody's typing in the chat, and I'll go ahead and end the EC live. Definitely, if you have any questions, you can either call in through our system or get a hold of your salesman or myself. I'm Dave Robinson, or Brian Coward, who's the product line manager for the EDM side. So any of us can answer questions either on wire or sinker. So thank you for joining us today for the EC Live. And if you definitely have any questions, get a hold of your salesman or one of the technical professionals at Makino. Thanks for joining today.